So, as you know, I do chat interaction on all of my streams. Okay. Is RSA only supposed to work for things up to 4 bytes? Great question. Let's make a Quarto Markdown document that explores the mathematics behind this question, right? Why are we using Quarto? Because I don't remember if I have LaTeX installed on my laptop. And separately, I'm going to conduct numerical computing experiments in the most popular numerical computing language in the world, Python. As you all know, this is a number theory class, which is why we use Python and Quarto Markdown, which happen to also be data science tools. I don't really remember how to do Quarto. Maybe something like this. Is there like an author? Are there any data scientists in the class? Wait, no, I don't have a last name. How do formats work? Oh, it's lowercase. That's why it looked wrong. Wait, what am I doing? Hi, it's me. What up? Okay. 4 bytes. Oh, I have no idea where I saved that. Did I save this in pictures? Yeah, it's in pictures. Look at that. Do you see it? And also .qmd is in pictures. And as we know, that's the wrong place to save things. Everything is supposed to be saved in downloads, right? Can I hear it for the downloads folder? Yeah, it has so much stuff in there. I deleted 200 gigabytes out of my downloads folder to download Monster Hunter Wilds. I had downloaded 2 virtual machines that were both exactly 100 gigabytes in size and never used them. I didn't even know I had them there. I had no memory of downloading them. Wait, HTML is not in quotes. That's not a quote. All right. FAQ. Let's block quote it. All right. Well, because there's nothing good on the internet, so anything we download is inherently trash, right? The only thing that's good on the internet is my takes, which I post everywhere. Have you noticed I'm going around commenting on my colleagues' LinkedIn posts saying, wow, assistant professor of computer science, that's my dream job? They love this. Every time one of them's like, assistant professor of computer science, so-and-so at such and such a place. And I'm like, hell yeah, that's me, lock in. That could be you. You only have to go to school for 10 years, right? 9 if you're fast. I'm blaming COVID for the 10th year. I think I would have finished on time. So how does RSA work? We recall, what do we recall? We recall that m to the e to the d is congruent, not equivalent, right? We decided it's congruent. Did any of you talk to the math faculty about whether I'm supposed to say congruent or equivalent?
I didn't have to say congruent.
Are you a math faculty?
No.
Ah, see, this was your option. I asked if you were a professor, and you could have. Yeah. It's congruent.
We don't need to ask the professors for this. I know.
Can anyone show me McNicholas's book?
I'll go get it, I guess.
No, you can stay here. No, it's fine.
This is your fault. Remember.
What should I call this thing? Oh, I'm calling it 4 bytes. Before class, I broke into Lizzie's office and stole a sleeve of Ritz crackers, and then I ate the entire sleeve in 4 bytes. That's why today's class is called 4 bytes, right? It is just a complete coincidence that 4 bytes is exactly 6 characters in length. No one could have anticipated that, right? So MED is equivalent to M P mod. Is that well? It's not curly brackets, right? It's these ones. These no anyone? Mathematicians? Yeah.
I came in late. What are we doing here?
We're answering a Discord question.
Okay.
You can work on the lab and ignore me if you want.
What are you trying to do?
We're getting there. Okay, I'm answering this question. Is that big enough? Can you all see that? Is RSA only supposed to work for things of up to 4 bytes? Okay. So, what we should ask, if we believe that some numbers might be finite, what could cause us to only have 4 bytes of precision, right? And my claim is that how we want that to look? No, the parens are in the wrong place. Is it these ones? Why is it so slow? Okay. Zoom. I want more zoom. Is that correct? Yes. Do I even need these parentheses here? I think I want to express it this way. Okay. And we can preview this. Yeah, that's what I want. Okay. So, what operation do we use to raise numerical value m? Quick question for the audience, those following along at home. Some of you are tuned in live and not watching the VOD. Why do we say m is a numerical value? What does it represent? Yes?
Because you can represent any message with numerical value.
Any message?
Any text message, anything that we can put in the computer, we can represent with numbers.
Ah, so you're claiming that this is related to the formal sciences concept theory of computation.
Perhaps, yes.
Okay. Can represent any. Why did I write represent any twice? Well, any value that can be represented in a computer. What is an example of a value we cannot represent in a computer?
The full numerical value of pi.
We cannot represent the numerical value of pi. Because, why not? It is transcendental, which means?
You can't express it as the root of a polynomial, right?
Okay, yes, that is true. And so why can it then not be expressed in a computer? How do you spell transcendental? S-C-E? S-C-E? E-E-N. I have never seen this word before in my life. Oh, yeah, transcendental. Okay.
Very relatable.
It has no finite. Has no method for finite expression in any language.
Well, you can do a little symbol.
Yeah, but we can't perform mathematical operations over that. Let's see. In any language suitable for usage within computational arithmetic, as implemented by sequential and combinational logic over resistors, inductors,
No method for finite expression in a computer.
transistors. We haven't defined computer yet. What's the one I'm missing? Capacitors. Who knows how circuits work? Okay. Okay. So, we recall that only some numbers can be expressed in computers, right? some of you have been implementing in RSA and C. What did we use instead of the integers? We don't have the integers in computers. They're not, because the integers aren't real and they can't hurt us, right? They're just like our feelings, right? No, are our feelings real? I've been listening to a lot of emo music, right? It's great. I am, as they say, living. So what do we use instead of the integers in RSA and C? This is not a trick question.
A subset of the integers that goes to 2 to the 64th minus 1.
We use a subset of the integers that ranges up to, what I meant was, okay, 2 to the 64 minus 1. That's its maximal value. What is the minimal value? 0. Oh, so these are the natural numbers in this classroom, but not in Professor McNicholas's classroom, right? Okay. From 0. Okay. How many messages can we express with that many, I don't know, numerical values? And this isn't like a necessarily leading question. Not all of them, right? There is no way to express more than 2 to the 64th possible messages. And there are many more than 2 to the 64th combinations of sentences in the English language. How many English language sentences do we think there are? Should be infinite, right? It's a recursively enumerable language. There exist finite encodings of messages. That's, yeah? Of messages. Wait, no, why did I write there exist? Is that it, right? No, I can't. Okay. There exists infinitely many sentences in English. And why is that? English is a recursively enumerable language. And we'll cite Chomsky, presumably 1967. I don't know for sure. Okay. Who's Chomsky?
Noam.
Yeah, Conrad Noam, right? So Chomsky was a linguist at MIT who did not have enough hobbies, right? So he accidentally invented the field of computer science, thereby ruining everything.
He's like a fossil now.
Yeah, he's like still alive, right?
So old.
Yeah, I was reading a paper he wrote in like 1959, which is when my father was born. Like, this person could probably be like, I don't know, a T-Rex. Hold on, what am I doing? Why am I in VS Code? Okay. VS Code is my favorite text editor. Or, no. Yes? It's my favorite web server. There we go. Okay. Okay. So, how many unique sentences can be expressed with 64 bits? And it's 2 to the 64. It's the same number as the number of integers, right? We agree on some encoding, and then may express. And we'll say circa because we might want to. Wait, can I use tilde for approximate in LaTeX? Is that fine?
I do.
Okay. Oh, should I? Yeah. Sentences. Okay. There is a little wrinkle here, though, which is that what do we do to each one of these sentences, right? One wrinkle. And it's this one. I have this one on my forehead. That's the wrinkle we're talking about. So If you get enough wrinkles, you get paid more because you seem older. Fun fact. So don't do skincare. What do we do with the messages to encode them, right? What do we do to the messages? Well, we raise them to some power, take them modulo some value, and reduce, reuse, recycle, which means loop. Who thinks globally and acts locally? Any global thinkers and local actors? No? Okay. Act not what your country can do for you, act what you can do for your country, right? Okay, so what do each of these things do? What happens when we raise a number to some power? Take m. M has some number of bits. No more than 64. To raise m to some power, we necessarily multiply two values together. Multiply two values together. The product of these two values requires as many bits to express as the sum of the bits of each factor. So let's say we have an 8-bit message. Say we square this message. The square requires 8 plus 8 equals 16. This should be all LaTeX-y. Oh, I had a question. I say LaTeX. Not everyone says it that way. There's at least LaTeX? And then no one does latex, right? Or LaTeX? Okay. I think we found some people in the MS program that got a different pronunciation from another school. I know when I was at my undergrad institution, everyone said LaTeX or LaTeX, but I think other people said a different word at my grad institution. But I didn't have any friends, so it didn't affect me. Okay.
I have a congruent citation.
Okay, thank you. Would you like to read it to the class?
Okay, I guess.
Thank you.
Definition 4.2.1 marker.
Wait, no, hold on. I have to transcribe this under intermezzo. Okay.
Want it?
Oh, yeah, sure. Thank you. Can you show me on the page where it is?
Yeah. Definition 4.2.1.
Okay, thank you. Definition 4.2.1. Okay.
I have to go in our office to get this.
How's she doing? Did you say hi?
Yeah.
Does she think we're weird?
Yeah. Very entertaining.
Okay. Given a natural number n, we say, oh, whoa, integers. Okay. A and B. Okay, so natural base of the number system and then integers within the number system. Okay.
So, yeah.
Okay. We say integers A and B are
Oh. Turned off.
Did I get penalized for plagiarism? I'm being oppressed. Okay.
You've been canceled.
Hardly the first time. Okay. We say the integer. Yeah, that's not a thing, right? Integers A and B. Oh, I like the formal expression much better. That's okay. Are congruent. Oh, yes, we can't just use the formal expression because the point is we couldn't agree over the n denoted. Ah, yes, okay. And that's definitely A equiv B. And we stylize that as P mod n, right? IE, what's IE mean? Is that true?
It's sort of like therefore.
It's like therefore and stuff like there's things that you're saying are equivalent.
Oh, equivalent, you say. So there's an equivalence relationship
There is an equivalent relationship.
between congruence and equivalence.
What if it's A to S? That is not something.
No, rectangles
Between the
are
first part of that sentence before IE and
Yeah.
then the second part of that sentence after IE, there is an equivalence.
So what we're
So, like,
what,
another way of saying this is
so what we're maintaining is that we can apply equivalences to subsets of languages.
Yeah.
Now, I mean, that's like the most interesting thing we've done today, right? Okay, the equivalence classes with respect to this, what does class mean here?
And equivalence class is like,
Oh, they're called congruence classes.
yeah.
Is that a, let's see.
Equivalence is defined for a page or two before, but it's not really that.
Oh, this is in a section called the ring of integers modulo n.
Yeah, because it's defining convergence.
I see. Very cool. And denoted. Are those box brackets around the A? Okay. We have, is that how you stylize that? Equal B in math BB. I've got the MSCS students in Portland referring to the R programming language as the Math BBR project for statistical computation, which is the funniest thing ever because we use the reals in that class for R, so we pronounce it as Math BBR, right? And then we also talk about the R project for statistical computation, so we say the Math BBR project for statistical computation. Everyone hates this. Anyways, you should all start doing that and see if people hate it here too. Okay. A equiv B P mod N close bracket. Is this gonna look right? No! Oh, yeah, okay. I was putting dollar signs in the middle. Okay. Wait, why are the A's crazy? Oh, I need to close Math BB. What does Math BB stand for? It's not Math Baby, right? Oh! I was always like, that's what I call my cat, right? And we're gonna, can I preview this? Okay. Thank you. I'm also going to look at what it says for equivalence in here. Equivalence relation is a set of ordered pairs of elements of S having the following properties. So equivalence relations are reflexive, symmetric, and transitive, right? Okay, and an equivalence class is the pairs?
It's all the stuff that's equivalent to each other.
Okay. So it's a subset.
Yeah, it's a subset of the.
Okay.
Yeah, there's all the stuff.
So under the integers modulo 3, 3n plus 1 is an equivalent class.
Yeah.
Over.
Yeah.
Okay. So you could say they're equivalent. I didn't disagree with that. What broke? Everything I do is stupid. Why does this not work? Does anyone know how LaTeX works? Is this wrong? Yeah, it is. When I installed Quarto, it broke MikTeX, and I don't know why. Okay. Does that look correct? Okay. Okay. I think that intermezzo should actually be smaller. Okay. So, in, let's see, under congruence, given some n, how do we generate n? N is equal to p times q, where p, q are in math blackboard primes, which we agree there's not a great way to express that sentiment. Taking m to the ed, okay, and here I use the expression mod n because I'm using it as an operation, right? Is at most n, therefore there are at most n possible messages that may be encoded under this key. Does that make sense? We take a message, we raise it to the power e, we raise it to the power d, we take it modulo n. No matter what we do, we cannot encode more than n unique messages in that way, because otherwise we're going to have collisions where the same two messages are encoded to the same value. Okay, does that make sense? Yes. Okay.
We need preface under if that's good. Oh yeah, I look at that.
Right, so this should be, wrong bracket, where are they? I don't know how to type. Okay. Separately. We are not working under one modulo, but we are actually working under two, and we will exist under the more restricted of these two. Working solely with respect to n. There is another modular set of integers that we are dealing with, and that is the uint64. We are also working within uint64t. Why does this matter? We cannot multiply together numbers larger than, I'm switching to code notation now. Under uint64t without incurring an overflow. This overflow is problematic for the following reason. We need to make sure that every message has a unique encoding because we have to decode that message back to something. When we overflow, that means there's two possible values that can be multiplied to get that number. So if I take if we take uint, no, I have to include the standard ints. Include standard int.h. We can generate two different values that square to the same number. Let's take uint8t, a, b, and c. We're going to set, we don't actually need a, b, and c, do we? We just need a and b. If we set a equal to some value, and what value should that be? What is a square that is between 256 and 512? What's 20 squared, right? Okay, yeah, 20 is 400. Okay. I'm falling back on my old habits. Okay. B equals A times A. Printf. A equals %D We'll square that. %d. And I want to denote this is under uint at. Okay. We have A and B. Okay. Let's check this. I've got to get this code to run. Uh, 4bytes.c. Really? Okay. Oh, it's slow. Okay. So, 20 squared. Oh, wait, did I put a period after the new line? That's hilarious. Under uint 8t, 20 squared is equal to 144. Right? No, not equivalent, congruent. Though kind of equivalent, because that's not really an equivalence class. And then what else are we going to do? Let's get out of insert mode. Let's yank that. We also want to find some other value that squares to the same number. And so this will be A equals 12, B equals A times A. Why is my caps lock on? No, it's not. I was holding shift. Okay. So what I want to demonstrate here is the problem with working with finite numbers. I am going to square something a large number of times, right? We can think of this as exponentiation, but we can think of it as squaring. It is trivial to find values that have the same square under some congruence class, okay? Oh, someone's messaging me on Discord. Is it one of you? This overflow is predictable and results in a loss of precise encryption. File name equals, nope, I have to specify it's in C, 1bytes.c. Okay, so we see that 20 squared is equivalent to 12, no, is congruent to mod 2 to the 8th. I think that's what I showed, right? So, why can you not store things bigger than 4 bytes? Well, if you take something more than 4 bytes, when you square it, it turns out you are actually going to get the same value as you would for a message that is 4 bytes in length. There is some corresponding 4 byte in length message, right? And that message is whatever this relationship is, which I don't know how to describe this. There's some other thing that has the same square under some mod. So, you are successfully encoding something, but you are trying to encode a message that is not an eligible message under your encoding scheme because you have a finite number of encodings and an infinite number of expressions. So you are getting whatever the shortest possible expression is that corresponds to that encoding. So if you try and encode 20 with small keys in uint 8t, you are going to get back 12. The same thing is going to happen under 64. Under 64-bit integers, you can store anything up to 32 bytes in size, 32 bits in size. Those 32 bits can correspond to up to 4 characters. Can you store more information than that? Yes, but not in ASCII or UTF-8. It is trivial to store longer integers by using some form of compression, and you can also store them by using larger integer sizes. Does that make sense? Okay. I don't think I did anything today that you can't do. I would like you to think about things this way. To motivate these remarks, computers do not always do what we naively expect them to do, but we can always construct a model that determines what they do predictably and reproducibly, right? I think that we spend a lot of time in our lives forgetting that the term science is in the name computer science, right? Why is science in the name? Because we can find naturalistic causes for things that happen in computer science. The naturalistic cause here is I have 64 transistors holding electrons. And there are only so many possible messages that I can store in precisely those 64 transistors. If I had an infinite number of transistors, I could trivially encode anything. I do not, right? And so there are two things that are capping how many bits you can store. There's how big n is, and n is a function of how big your primes are. N is exactly as big as your two primes put together in terms of bits, not in terms of number, right? And then there is also whatever type you are using for your arithmetic calculations, which in my case was the uint 64t, and that meant that I could always encode 4 characters and I could never encode 5. If you want to encode 5 characters, there's a lot of ways to do that, but the way I would do it is encode 4 things at a time. So that is my recommendation to you. I'm going to write that down, and then I'm going to go walk around and help you with the lab, which you may be working on.
Question regarding next week's midterm.
Yes.
Are we allowed to use any notes?
Yes, you can use anything.
Cool.
Yep. Recall the subject name, computer science. Exists naturalistic causes for all results in computing within reason. These are frequently multiply specifiable in formal mathematics, LaTeX, linguistics, a field with which I am not familiar with notational conventions, philosophy, using formal logic, likely also under LaTeX. Cass, do you use LaTeX in philosophy classes? What do they use to specify formal logic?
A whiteboard, and they just sort of use the first order logic.
Okay.
LaTeX would really be useful.
Okay, likely also under using a whiteboard. Okay. Programming, not equal computer science. Using programming languages such as Python. How do you write asserts in Python? Is this? It doesn't fit on one line. Hold on. Is that a valid Python assert? Does anyone know?
It should be. I don't think you need the parentheses, but it shouldn't stop.
You don't need the parentheses?
I've only used asserts in the context of the PyTest plugin, so I don't
That's
know.
crazy. Okay, yeah, okay, I see. It's a control flow statement. And I think we're going to learn. There you go. That seems fine, right? I really don't like that that's a control flow statement, actually. Okay. Cool. Is log defined? How do I specify a log base something? Is it?
It's just
No. That?
and the other one.
We're good. We'll just do the parentheses.
Probably. I think it's in CUDA. Then you should use OpenGL. Do you have an Intel CPU?
That requires salt.
You might be able to do this. You might be able to use the SIMD vector instructions. Are you on an Intel or AMD? I'm way more familiar with Intel. You're on a Mac, so you're on an M1. No, that's an older Mac, right? I bet that's an Intel CPU. But you think that's an M1? Okay.
I think that's the last M1. Or the
M1 vector operations in GCC on Mac. I don't know. Look it up. If I were you, I'd be writing CUDA in
I
Colab.
think ND array was written in C. You should be able to use it in several different languages.
No, it's
Like
clearly written
has
in
ND
Rust.
array bindings as well.
Mm-hmm.
That's what you can use if you're using Rust or PHP. There's also an algebra library.
Yeah. You shouldn't do linear algebra on a CPU. That's what GPUs are for. That's why God invented NVIDIA. You know what you actually should be using is Fortran. Well, I think that's true, right?
Isn't NumPy written in Fortran?
No.
There's a tiny part.
Yeah, but no. NumPy
For
is like...
legacy reasons, I think.
Yeah.
There's also a different part of GCC.
Well, Fortran is just like a good way to express some ideas. And because the language is ancient, it's trivial to transpile it into any given thing, right? So, like, yeah, stuff is... Whoa! I am banned from doing numbers. I'm so intellectually lazy with this stuff. Oh, that broke.
That would be like the whole project. Is this something you'd be able to just quickly look at?
Something's broken. Yeah, if you're doing linear algebra, you should not be doing that in C. That's not what C is for. C is for writing servers that service 1,000 clients a second and things like this. Then it should be written in CUDA. So what makes linear algebra fast, right? Yeah, vectorization, right? So historically, it was loop unraveling and vector operations on CPUs, and that's why MATLAB was fast. And then Python won the GPU race and took over the world, right? But it's always just whatever the longest field is with the simplest operation. And what is C good at? Doing very complicated operations on a small field, right? Because it's from a different era of computing, and you did complicated operations over small numbers, because memory was expensive and compute wasn't. That's no longer true. Memory is now free. So yes. Now, that said, there is a reason CUDA is 1 bajillion times better than everything else, right? But you should be figuring out a way to get things in a PyTorch data frame or a CUDA kernel somehow.
If you want to do Rust, there's always CUDA.
No, there's not. That is false.
It's a little bit of a lie.
There is not CUDA RS. There is the negation of CUDA RS. Jimmy, have you looked at polars at all?
Not really. A little bit. I know what it is. But
Yeah.
It's just panels with Rust.
Yeah, which I was really surprised by, because Pandas 2 is going to come out someday and just make there be no reason to do that. Because, yeah, why would you write pandas in Rust? It doesn't make sense to me.
It's just that,
Was someone bored?
yeah, I bet that's it.
That-
Also, writing Python things and writing packages for Python in Rust is way easier than doing it in C.
I mean, pandas should be implemented on top of Arrow, which is on top of HDFS, which is JVM. Well, I mean, none of us want that to be true, right? But the correct way to solve this problem is Rust needs to implement Hadoop distributed file system, which it has not successfully done yet, to my knowledge. The Spark Rust kernel is probably pretty close, but there's no way it's complete.
and seeing what happens. Hard makes sense. But I don't like the idea of having to have internet access to run my code. I don't have a CUDA capable device.
Oh, if you have a set.
Well, I'm looking at, hey, I'm looking at this.
That's true.
I think what based on what
Yeah.
previous thoughts.
Like, this is family obsessed.
So, okay, on the previous page, when it said family obsessed, I think just like the set of sites. Then all the sites that are brings up.
Okay.
Not fun. You said it's a coding and all the elements
Yeah.
of.
It's more just like a personal project, but I do want it to scale up because it's like, what is it, like 4 bits is 2 to, is it 2 to the 4th vector? And like, I want to be able to simulate like, preferably like 100, but that's great. Two bits has 4 states. Both of each of basis vector. So then it's a 4th dimensional. Yeah. Yeah, 2 to the to represent.
Because the problem is, so 10 bits stores 2 to the n values. It's so 2 bits stores 3 to the n values.
Wait, 10 bits source 2 values. 10 bits stores
Every possibility for representing those multiple things that have a set.
Two bits is 4 states right now.
Yeah, there's yeah.
One of states 2 to the 2 to the n, and then it's the number of bits.
Yeah.
So then that would be 2 to the 4th.
No, 4 states mean to me. Now I broke my brain. Are there 4 states? Yes.
Okay.
So how do you store those 4 states? You only need 2 bits in range to store 4 states.
Yeah.
And how many states are there?
8.
Yeah. Well, then that's linear. That's gonna be
What?
And that's
Isn't it?
Yeah, there's no.
Well then,
beginning.
4 bits. Let's because it's in check. Even if we just store them at 4
I don't
bytes
think
too.
it's 4 states.
For
It's
2.
the power set of the states.
The power set of the states. So like 2 bits would have states of.
Well, the thing about the reason
2 bits have states of 0, 0, 0, 1, 1, 0, 1, 1.
Yes. And your quantum machine knows for each of those 4 states which ones are possible.
It's just
Too
saying.
many things to explain. Right? It is the power set. So if it's expressing this as like the size of the power set, that's to express which elements the power set are present.
There is an element
That requires
R
4.
and N for each
Yes or no for each of the 4 possible states.
Oh yeah.
Right, so 4 states, yes. We can store the number of states, but we don't need to store the number of states. We need to store a language to determine which
Okay,
elements of the number of
so I
states
think
are
it's
present.
saying
That language has coordinates.
that
2 to the 2 to the n.
Oh okay, yeah.
I have 3 bits. 8 possible states.
Okay.
An 8-bit vector
So-
to encode the presence, whereas
I'm not sure what it is out
right?
of
That's your problem mostly.
but I know that AFI is a set
8-bit, yeah.
In the way that.
because all
Is a set. Oh, so I think there's this thing.
all
that
elements
thinks that-
all elements of fancy are sets.
Classical language or 3.
And so I think
You need to store with each state. You need to store a complex number.
But aren't they like
I don't think that matters.
well because for all J's
So there's like really important ones with like phase and feedback and stuff like that that you need to store like precisely, right?
Well, it's just, I mean, I don't know exactly.
So I would have like.
The most basic one possible. Okay. Hello world.
parallel
The hello world of it. That's the first part of their last. Maybe you made it. Yeah, you made it. It's amazing.
An iconic living legend.
What I'm saying is that I, like the range, not the range.
So just make it really long. Gotcha. Like I know like
Use the range before.
That's really long.
That's how many. The big I is like. However many indexes, however many sets you have, so fancy that.
There's a couple of things that you can use.
Do
But
you think
Would that be worse? I mean, I haven't.
do you think you
I don't know why.
if you want to do it the proper way, as in you want to actually write something that companies would use, you should use CUDA.
I think the thing is that
If you want to write something that will help you understand what you're doing and want it to work,
so
I don't know.
for a set,
CUDA gets
be
really
a
complicated
certain
very
I think it's that one, and neither of us can remember that. So that's kind of a non-starter.
I think
yes.
So right. Okay.
like if you wanted to do a version 2 where you optimize things at shit time, I would say do that in CUDA. For version 1 you're just trying to understand how things work.
Yeah.
Try to use whatever helps you.
Python. Let's use this.
Let's use whatever helps.
Still.
Into the notation.
Until we hit a wall.
Use what?
Should we like PyTorch it? Yeah. Like how we can.
or that might be a free image depending on where it is on the bottom.
Yeah, just use Python and
On the top is the image.
and number line.
On the top is the three.
Python not Python.
I think it's probably DJ.
Yeah. That's a great question. I don't know.
Okay, that's what I was because it looks like this doesn't make sense. It looks like this is got
Which one is this? Which number is this?
It's number 2.
Okay, this big U. Where did the big U come?
Oh, no,
union,
not even
it's
just that.
a union
Not
of
even
all
just
J's
like
and
that.
J.
Like, not like.
So if you had like J that is 1 plus J that is 2
That's a good way of describing it. And I'm just kind of telling
union, so you're adding them all to the possibilities, but then if you're only going to pull one
yeah,
from
I just don't. There's so much to do, and really, like, you're asking about it, not having that much to do with just business. So,
Oh, no, I see.
I like that too. Oh, you just have the file that's the, like, IP on it. And as long as you have the extension.
Right.
So
Oh, I'm sorry. There's a lot of stuff.
the union of the thing. Oh, we did.
But it's just
in
like
that,
something where you take the
like,
R.
for instance, talking about family.
Yeah. I don't know.
Yeah.
Okay, but the other thing is, yes, I wrote down on Monday, I was late and I missed
But
it.
then
This
that's
is what was
because
on the board when I got there. Was the U with the index to infinity. I don't know what that's about. And also, that's not the same thing that is there. So never mind.
By the way, why else is that?
It's one of those things that it makes sense when you do it every sentence anyway.
For every element in the index. Okay, I wrote the index set for every element in the index set.
I'm confused.
Wow.
Doing operations mod.
Yeah.
What doing operations mod means. Specifically for the implementation of slides, there's this thing where like we don't need the second half because it's like
The function, okay, so as a function, the input,
because we're doing it on
the
it.
union of all j's and j, yeah.
So we put a function for the
So I have, I think,
Also with mod XP, I don't know what that's for. I'll figure that out when I get to it.
Or finagle the parentheses.
fine.
If you can finagle the, if you can mangle and finagle the parentheses.
Beta?
To get
Or
the,
A or D.
That's how
and
you
you don't have to do it.
better.
So.
I want that. Not necessarily
That's
better.
a given.
No, it does go the other way.
Some do.
I got
I don't
some,
believe that's.
I got some notifications about schedule
I'm almost
change.
sure.
Actually, but they do this way. Well, that's
No,
well, yeah.
I read it and I was like, I don't understand what this means.
We're going to.
Is that
We're going to
the
make a
thing that
strong plan.
moved, that they moved up, that they moved down, closer to us?
Yeah. Yeah. Okay. No.
If we
Why
have
not?
some element.
We would have that here if you had. These do no different. This mod round modifies the equivalent. This specifies that we're using a form of equivalent but it's in that mod C. Yeah. I think it is that for equivalent to mod.
That part of my brain gets really tired.
Why is that? Because this is implied by
It's the same, but it's
for
not.
mod 3. You distribute the mod operator to get
Like this,
Is one, right?
Yep.
Because that's the remainder.
And then we switch to programming notation.
And one mod 3 is also just one because the mod is something smaller than the modular operators. It's just itself.
That's another equivalent.
5 mod 20.
Oh yeah, mod 3.
2? And anything less than 3. Everything? Are you driving at something specific?
So
What?
this 4% 3 is 1. 1% 3 is 1. 7% 3 is 1. That's what we mean by equivalent.
Oh no, it's also yeah, no, you're right. Okay.
Okay.
So
Here, so got this.
once you choose to put this line here,
so what is this
then
mod operator?
you've been given these two
This
things
line
here.
is
Choose to
doing
put this
this.
line here. Once you've chosen
not
to
a
put the
difference.
reference lines,
Okay.
you derive from
Okay, sure.
those 2 points in the line that you've already given.
So we just kind of we're able to ignore.
I think there's that.
Well, it's not
It's just setting up the let and assume.
So those is just.
These are you see, this is
Yeah.
right? And the pink ones is that.
Cool. This is just for a reminder for me. And so we're looking for AX plus BY plus CY mod. Not to indicate anything weird stuff, but just to like give it a sense of like what's included or is this.
So it just so happens we're only using that separately different operations.
Which is to say,
And that operation is modulo inverse.
yeah,
Or section lambda.
M equal D. Okay, so it's
We could either use a bookmark or we could what else are we looking? Well, we actually know what this is.
what? Okay, good.
I'm trying to get
No, hang on. I think we can make it up. So, like, because you can plug kind of all of this
Do what we're doing in here, but outside of the sun, inside if that's okay. Yeah.
I did not know that. Yeah.
It was a
It's been sunny
second.
all
Do
day.
you have any questions before you leave?
Not yet, no, not
Cool.
yet.
Thank you for the technical.
So because all of this is there, you can just ignore. Does it ever cancel out? Is that true? No.
Yeah, pretty much. So, this Y is like we're trying to get M, but we can argue that subtract 1 from this. We're getting 1. So,
I used in other contexts for doing something else sometimes. They used it. It just became standard a while ago.
some value equals there's a total then you can divide both sides by n.
N is n to a value is 0 to n.
That's perfect.
Okay.
Why is this one just equal to 1? Is that n equal to 1?
Right.
So now what do we have? N to some power is equal to 1. That power is the GP.
Right.
Use the extent equally however it defines size. Any questions? Good? Yeah. Cool. Take care. This all happening modules. Happening modules.
More lambda.
What is d dy mod y? What is d times y multiplied? 0. Why is that?
I don't have a solution for much enough.
Yeah, for reasons we can.
Which is good.
Yeah, that's fine. 3n percent n is equal to 3.
Yeah.
That's it. It's a little direct. Right? Because it's like this. Okay. Anything we won't plug right now. We'll have to get over it.
Anything
Yeah.
times n was 0. Okay, so you can represent all of those as x.
So, what's dy mod y?
0 always.
So now they actually equal 1 mod y.
Oh, that's what that cancels because, okay. Oh. Okay. Alright, so this is always, okay. I think that makes sense. I think it's enough for me to implement that function. There's a different, like, kind of limited thing. You brought up, like an optimization, basically, which is like doing a lot of operations by modulo to like enable you to do stuff more than like 3-bit threads. And that seems like a different. It seems like you're doing this as a necessary consequence of the math, and not as an optimization. So what is the taking stuff by mod for optimization purposes?
Just for that. So every time you square it, make it quick.
when, where, and how.
So you raise 10 performance power.
Yeah.
How many digits is that? Yeah, right. But we don't have to do it all at once. We can square it and then divide it. Because 10 is 5, 5, 3, 7 is equal to 10 to the 3 to, I don't know how this is.
But half of that.
Yeah, right.
Then what happened in C?
5. 10. So how do we do that? Well, that's the same as 10 squared. It's probably
Why not?
Even all this logic. Different small value. We can apply that concept.
Function and take on, for instance, and try to change that instance instead of returning different instance.
And that keeps them from
Like if I just do,
Because this thing's very different, but the square one is good.
if I just test it out.
We don't have to.
The qubit is
we drop
qubits
we drop
divided
down
up
to
here.
16
Yeah,
squared.
that's all.
We drop down to 16.
Okay.
Wait, no.
Oh yeah, I missed it.
Yeah, no,
Like,
like
literally,
literally,
we've been,
Yeah.
that's,
But this thing
I
is
was in
capital.
modern, I was trying to write a double for loop, and I'm like, what the fucking working, this for my main method, I did squiggly brackets instead of a colon, and I'm just, I've been doing
Really
C.
the difference between infinitely important ones and not.
Okay. That helps. And we just do this, that sort of function in a couple different ways.
It's all about human funding. It's all, all about the undefined number.
Yeah.
If it's zero computational cost, it's not even
Just do that.
and also zero computational cost, yes. Valid.
I think that's much more. Thank you.
Yeah. What?
Yeah, two next question.
Yeah.
If I have a bazillion, I want to be able to make classes that combine classes and bigger, objects that combine with objects and bigger objects. I'm confused on how to optimize this, and I think there's not like a good
You
way.
optimize by not using objects.
Okay, but like,
So what exactly are you trying to do?
I want to be able to, so I'm starting with qubits, and then I want to be able to move on to qubit strings. Because that's really what we care about, because we don't care about, eventually it's not care about, we care about the individual qubits, we take the tensor product of them, and then that's what we care about. But in order to do that, like, I'm changing larger and larger vectors, and that seems probably really a list of qubits. But I won't be able to.
Like a qubit is just a vector. Making it a class.
Thank you.
We
Good.
could just use the and the it's just like that. And if we could make it a
if it's like a different like this where you basically and that's great.
Look for a solution in the case, because it's not.
Okay. I'm also assuming that there's more general.
Yeah.
In our saying the 4 bytes of information to the square. Now, if you happen to have 128 images that might be here, please let me stay on it.
I was going through a thing and then I got distracted by an outlook, so it's a
I'm trying to interpret the scrollings. This says, I think these with the square going outside, wouldn't you tend to do it like this? And to the half of the problems.
Yeah, I can go that way. Can you?
Those don't seem.
No, can you? Can you? This one? Actually, that one. Do the 6 is equal to the 3 times 2 is equal to the 3 times 2 is equal to the 2 times 2. That's a different algorithm. That's trying to figure out. Oh.
Because you're right, like when you move them on inside of the square, basically do this. But based on this, it seems like
Yeah, it's
it would be. Okay.
I am never totally clear on the difference between exponentiation, multiplication, and addition. Like, they're still the same basic operation.
Actually, okay, yeah, I still think it's
Yeah, no, no. Once you have an
So this is. So that's wrong, and this is. I don't think.
nothing, because this is supposed to be addition. That's why I stopped. In this case, 2 equals squared, and also equals 2 to the squared. Keeps remaining constant.
I'm still streaming. What's up, YouTube?
Do any of you want this card on markdown, or should I throw it into the sun?
I would like.
Okay. I think it's important to reveal how the sausage is made, even if it is a delicious vegan sausage. I'm so glad I turned off the stream in time. Is there markdown highlighting? Oh, that's...
Wait, isn't there like a LaTeX bot?
Not in this server, because Jimmy won't set it up.
You can add it yourself.
Why would I do that to my class? You're the one that uses LaTeX.